Hi class, for this assignment we're going to take a look at piecewise defined functions. And for piecewise defined functions, you technically have a function, which in this case they're calling g of x, which is composed of technically two conditions. So what I'm going to do is I'm just going to graph them on the side. So in this case, let me make this a little bit thinner. The first function, so we're just going to let g1 of x is equal to an x squared. Now, it's perfectly fine if you need to basically plug in coordinate points, but I'm just going to jump to the actual sketch of the function. In this case, that's what the x squared looks like, which happens to be the first one. We'll cut the pieces in a minute, and then our g2 of x is equal to negative square root of x. So this is a square root function that technically has a negative. So because of that negative, instead of your actual, square root going in this direction, it's going to go from the origin to the bottom. Now, that would be the negative x squared. Now, the next portion is crucial because we're going to be doing pieces. So your first function, x squared, is only true for x being less than 0. That would be this piece. So technically the piece that we're going to be transferring over, it's less than 0, which means you're not going to include the origin, and it's just the piece to the left. So that would be the piece of the parabola that we technically need. The second one says x is greater than or equal to 0. So technically this is x is greater than or equal to 0. So because you're including 0, you're not going to fill that in. And then technically it's going to go in this direction. So your main answer happens to be that. This is your function, in this case, g of x, which technically represents a function that is composed of multiple pieces. Let's take a look at example B, and same idea as before. We're just going to graph them. So let g of x equal to an x to the third, and then g2 of x is equal to an absolute value of x. I'm just going with 1 and 2 in the order that they're actually appearing. Now, for the first one, it's an x to the third. So your x to the third looks like this. We actually graphed it in the first exercise. And then the second one, it's an absolute value. So absolute values is just going to be that v. And then we need to technically look at the pieces that we're going to cut. So your x to the third, it's only going to be good for x is equal to -1. So this is -1. That means that you're just going to get this piece. Now, if it was a value that's not easy to evaluate, at x is equal to -1, your your g1 of -1 represents a -1 to the third, or -1. So the coordinate point that we need, it's technically -1, which is here. And it says less than -1. So we're just actually going to cut this piece here. That's what we're going to be actually retrieving. So you're just looking at this piece here. Your second function happens to be for x is greater than or equal to 1. That's 1, that's 1. So it's going to be this portion here. So let me transfer that in red. So that would be 1, 1. And technically it's just the portion of the v that's going in this direction. Both of these are solid. This is our function, which we happen to be calling g of x. Let's take a look at the last one. And the last one looks a little bit complex, but no, it's actually perfectly fine. So we'll just let g1 of x is equal to 3, and then g2 of x is equal to 5. And all we're doing on these is basic sketches. So let's take a look at the first one. This is going to be 3 for x less than 0. And remember that this is just y is equal to 3. That's what it represents as a function. So this is 1, 2, and 3. And then the next one is 5. So 1, 2, 3, 1, 2, 3, 4, 5. And then our final answer, we're going to have to look at the domain. And x less than 0, so that would be here. It's going to be 3. So you're just retrieving that piece. So 1, 2, 3. Less than 0 means you're not including the value. And then greater than or equal to 0 for the function y is equal to 5. 3, 4, 5. This is solid. And this is your actual function g of x. So that is technically our main solution for the piecewise defined functions.